NVIDIA released a neat feature a while ago that's part of the control panel on Windows where you can create custom resolutions for your monitors. Part of this includes the refresh rate of the monitor, so you can enter a custom value to essentially overclock your monitor. Overclocking your monitor will allow you to run the LCD panel at a rate higher than 60 Hz, usually up to around 75 to 90 Hz. The main benefit is that you can run games at a higher refresh rate and actually see the difference. Your monitor only goes up to about 60 Hz, and so when your game is running at 70, 80, 90, 100 Hz, you won't actually be able to tell that difference because it's over what the monitor can display. Keep in mind, however, that most popular brands don't allow their monitors to exceed 60 Hz, and so your results will wildly vary. So let's go over how to overclock your monitor on Windows and Linux. The steps for Windows are fairly easy. Just right-click the desktop, go to the NVIDIA control panel, hit Change Resolution on the side panel, and then Customize at the bottom. Click Create Custom Resolution, and bump the refresh rate up by 5. Hit Test in the bottom, and the GPU will try to output at that refresh rate. If all went well, then you should see the Test Successful dialog box. Repeat this and increase the refresh rate by 5 each time until it stops working or your monitor starts doing weird things. When you reach your monitor's limit, then hit Yes in the Test dialog box to save the custom resolution. If it doesn't work at all above 60 Hz, then your monitor probably has a lockout on it to prevent unsupported configurations, so try another monitor. Hit OK on the Customize window and scroll up in the resolution list. Your custom resolution will be up at the top with the refresh rate drop down on the right. Just select the refresh rate you want and hit Apply. Some games won't recognize the higher refresh rate in full screen, and this is usually fixed by running them in windowed borderless mode, so that the display manager can control the monitor's refresh rate. For Linux, as usual, this is vastly more complicated. NVIDIA released this function on Windows, but the Linux version of the control panel doesn't have this, so we have to do it manually by creating a custom EDID file. EDID, or External Display Identification Data, is a file that's stored on the monitor. When you connect a monitor to your PC, the PC reads this file to know various details about the monitor, such as its resolution, refresh rate, and DPI. A cool feature of X11's video server and with the NVIDIA driver, you can pass it a custom EDID via the xorg configuration. So in general, the idea is to read the current EDID from the monitor, edit it with our custom refresh rates, and then link that back to X11 in the NVIDIA driver for it to use with that monitor. The first step is to read the current EDID from the monitor. Go ahead and install Wine32 and nvidia-settings. If you haven't already, you'll need to add the 32-bit architecture for dpkg with sudo dpkg add architecture i386 and sudo apt-get update. Then you can go ahead and install Wine32 and nvidia-settings. Extract the EDID from your monitor, simply open nvidia-settings, click your monitor on the left, and hit Acquire EDID. Save it to the desktop. Next, we're going to use Analog Way's EDID editor, download it from their website, extract the exe somewhere, and in the terminal, you are going to just do wine space and then drag the exe there. This will open the installer, run through the installer, and make sure that the Launch AW EDID editor at the end is checked. The editor will open. Go ahead and open the EDID file that you saved from the NVIDIA control panel before. It should still be on your desktop. Go to the Detailed Data tab and click CVT Wizard for the first timing block. Change the refresh rate to the same increment of 5 as before, only this time you have to resave the file and restart the X server each time to test it. Save it, but make sure to save it as a copy with a different name on your desktop. Now, edit your xorg configuration, sudo nano etc x11 xorg.conf. Paste this in if it's empty. If there is already a configuration there, just add the EDID option line to the screen section. Change the monitor to be the correct display ID. You can get this with the same xrandr-query command. The monitor name will be something like HDMI-2, DVI-1, or DP-3, depending on where the monitor is plugged in. Save the file, log out, and log back in to apply the changes to X11. If you get black screens, then you might need to lower the overclock on your monitor, or your monitor might not support it. If it was successful, then edit the EDID file again and try another 5 Hz increase. Repeat this until it stops and you found the limit of your monitor. So there it is. Keep in mind a few things that you might experience. Overclocking the monitor will not reduce LCD ghosting. Higher refresh rate monitors like the 144Hz ones have much less ghosting. Overclocking the monitor will make it run hotter. The LCD driver board has to run faster than the manufacturer intended, and it will reduce its life. Certain display interface connectors won't be able to handle the resolution change. Single link DVI can't handle 1440p at 75 Hz. You'll need a dual link DVI cable, same for HDMI 1.1. Make sure to head over to the Level 1 Tech forums for the full written article on this, as well as some thoughtful discussion. If you have any questions, ask us on the forum because YouTube's comment section is awful. Get yourself subscribed to catch my future videos, and I'll see you next time.